projects. In this video, we are going to explain about the project title Rule-Based Intrusion Detection System using Logical Analysis of Data. Introduction. The project acknowledges the growing risk associated with the expansion of internet usage. As more devices connect to the networks, the potential for security breaches and cyber attacks rises due to unfamiliar environments and increasing online activity, highlighting the critical need for systems that can ensure network security in real time. Detecting and responding to intrusions as they occur is crucial to mitigating potential damage from cyber threats. IDS, Intrusion Detection System, are presented as robust technological solutions designed to monitor network traffic continuously. Their purpose is to identify and flag potentially malicious activities or anomalies within the network. The project focuses on employing a specific approach to intrusion detection. It utilizes the logical analysis of data (LAD) method, which is a behavioral based technique. This method involves analyzing patterns within the network's behavior to identify irregularities or potential threats. The project intends to evaluate the efficacy of the LAD logical analysis of data method by using the NSL-KDD dataset. This dataset is widely recognized and used as a benchmark in the network security field. The project aims to compare the performance of the proposed LAD method against other existing machine learning algorithms, likely by assessing their ability to detect and respond to network intrusions using this standardized dataset. Objective. The primary aim is to create an intrusion detection system (IDS) based on rules using the logical analysis of data (LAD) method. This IDS intends to identify and prevent intrusions within network systems by employing a rule-based approach derived from patterns and behaviors observed in network data. The project plans to evaluate the effectiveness of the LAD method by comparing it against various established machine learning algorithms such as support vector machine (SVM), Navy Bayes, random forest (RF), and decision tree (DT). This comparison will be executed using the NSL-KDD dataset, a recognized benchmark dataset in the field of network security. The project focuses on assessing the performance of different methods using specific evaluation metrics, accuracy, precision, recall, and FN score. These metrics are common in machine learning evaluations and provide a comprehensive understanding of a model's performance across different aspects like correctness, completeness, and balance between precision and recall. The overarching objective is to develop an IDS that stands out in terms of both accuracy in detecting intrusions and real-time performance. The aim is to create a robust system that not only achieves high accuracy in identifying intrusions, but also operates effectively in real-time scenarios, responding swiftly to potential threats without compromising on accuracy. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following steps. The first step is importing the packages. This step involves bringing in the necessary libraries and modules required for data handling, visualization, pre-processing, feature selection, and machine learning tasks. Commonly used packages like Pandas, NumPy, Matplotlib, Seaborn, Scikit-learn, and more are imported here. Exploring the dataset. This part involves loading the NSL-KDD dataset into the environment and conducting an initial exploration. This exploration encompasses tasks such as understanding the structure of the data, checking for missing values, statistical summaries to gain insights into the dataset's characteristics. Data processing. Creating a Pandas data frame to organize and manipulate the dataset. This step includes cleaning the data by handling missing values, dropping redundant or irrelevant columns of features that do not contribute significantly to the analysis or the model. Visualization using Seaborn and Matplotlib. Utilizing Seaborn and Matplotlib libraries to visualize various aspects of the dataset. This involves creating plots, histograms, heat maps, or other visualizations to understand the distribution of data, correlations between features, class imbalances, or any other patterns present in the dataset. Label encoding using label encoder. Converting categorical data into numerical form using techniques like label encoding. This step is crucial as many machine learning algorithms require numerical input rather than categorical. Feature selection. Employing select percentile from scikit-learn using mutual information classify has the scoring method. This step aims to identify and select the most informative features that are most relevant to predicting the target variable. Splitting the data to X and Y for machine learning. Separating the dataset into input features X and the target variable Y. X represents the features that will be used to make predictions, while Y represents the variable that is being predicted or classified. Building the model. This involves creating and training the machine learning model using the processed and prepared dataset. Depending on the project's objective, a rule-based model using the logical analysis of data method is developed, or other machine learning algorithms are implemented and evaluated for intrusion detection based on the selected features. Training the model. After data pre-processing and feature selection, the selected machine learning model, such as the rule-based ideas using the LAD method or any other chosen algorithm, is trained using the prepared dataset. This involves feeding the model with the input features X and the corresponding target labels Y to learn patterns and relationships between features for intrusion detection. Flash framework with SQLite for sign up and sign in. Implementing a web application using the Flash framework, a Python based web framework. The application includes functionality for user sign up and sign in. SQLite, a lightweight relational database management system, is used for user authentication and storing user account information securely. User gives input has feature values. In the application's interface, the user provides input values for various features related to network data. These features represent different parameters or characteristics of network traffic or behavior. The given input is pre-processed for prediction. Once the user input is received, it undergoes pre-processing steps similar to those applied during the initial data processing phase. This ensures that the user provided input is formatted correctly, encoded appropriately, and made ready for input into the trained model for prediction. Trained model is used for prediction. The pre-processed user input is then fed into the trained machine learning model. The model employs the learned patterns and relationships to predict whether the input represents normal network behavior or indicates a potential intrusion. Final outcome is displayed through front end. The prediction outcome from the model, whether it's flagged as an intrusion or not, is displayed through the application's front end interface, providing the user with feedback on the input's classification as normal or malicious behavior. Algorithms used to implement this project, we have utilized the following algorithms. The first one is SVM, support vector machine. SVM works by finding the optimal hyperplane that best separates different classes of data points. For intrusion detection, it identifies a hyperplane that effectively distinguishes between normal network behavior and potential intrusions. SVM, support vector machine, can handle both linearly separable and non-linearly separable data by using various kernel functions to map data into higher dimensions where separation becomes easier. SVM kernel. Kernels in SVM are functions used to transform input data into a higher dimensional space. This transformation allows SVM to find a hyperplane that separates data points more effectively. Different kernel functions like linear, polynomial, RBF, and sigmoid are used to handle different types of data distributions. Navy Bayes. Navy Bayes operates on the Bayes theorem, assuming feature independence. It calculates probabilities of a data point belonging to a particular class based on the conditional probabilities of features. Despite the naive assumption, Navy Base is fast, simple, and often surprisingly accurate, especially in text based or categorical data classification tasks. Decision tree. Decision trees use a tree like structure to make decisions. Each node represents a feature, and branches represent possible values. By traversing the tree based on feature values, it reaches a leaf node containing the predicted class label. Decision trees are easy to interpret and visualize, making them useful for understanding the decision making process. Random forest. Random forest is an ensemble of multiple decision trees. Each tree in the forest is built on a random subset of the data and features. The final prediction is made by aggregating the predictions of individual trees. Random forest mitigates overfitting and improves accuracy by introducing randomness in the learning process. LAD, logical analysis of data. LAD focuses on deriving logical rules from the data. These rules are akin to if then statements based on observed patterns in the dataset. In intrusion detection, LAD aims to create rules that describe normal network behavior and rules that identify potentially malicious activities. It involves analyzing relationships and dependencies between different attributes or features to create these logical rules. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Comparison graph. Comparison graph offers a visual breakdown of how a model performs across essential evaluation metrics. These are the comparison graph of NSL KDD dataset. Models are compared with the parameters accuracy, precision, recall, and FN score. This is the accuracy comparison graph. Here on the x-axis we have accuracy score and on the y-axis we have algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positive and true negative, to the total number of instances. This is the precision comparison graph. On the x-axis, we have precision score, and on the y-axis, we have algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. This is the recall comparison graph. On the x-axis, we have recall score, and on the y-axis, we have algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the FN comparison graph. On the x-axis, we have FN score, and on the y-axis, we have algorithm name. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. The algorithm which is performing best in all the performance metric will be used for prediction. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes pages like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost this and port this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register, but I have already registered. So click on sign in link here. Here we need to enter the username and the password which we have created and then click on login. We have logged in successfully. So here we need to enter all these parameters to predict whether attack is detected or not. Before entering the parameters, let us understand the parameters. So the first one is service, indicates the service or protocol type, example HTTP, FTP, SSH, used in the network connection. Flag represents the status or state of the connection, example FIN, SYN, RST, based on the TCP protocol flags. SRC bytes, that is source bytes, the number of bytes sent by the source host in the connection. DST bytes, that is the destination bytes, the number of bytes sent to the destination host in the connection. Count refers to the number of connections with the same attributes, such as the same destination host service, etc. Error rate denotes the percentage of connections that have SYN errors among the connections probing for the same destination host and port. SRV error rate, similar to error rate but calculated for the same service. Same SRV rate, the percentage of connections that were to the same service among the total connections. Different SRV rate, the percentage of connections that were to different services among the total connections. DST host SRV count, the number of connections to the same service has the current connection within the previous 2 seconds. DST host same SRV rate, the percentage of connections to the same service among the connections to the same destination host. DST host different SRV rate, the percentage of connections to different services among the connections to the same destination host. DST host error rate, the percentage of connections that have SYN errors among the connections to the same destination host. DST host SRV error rate, similar to DST host error rate but calculated for connections to the same service. These parameters are often used in analyzing network traffic to detect potential intrusions or anomalies by establishing patterns or deviations from normal behavior within a network environment. Now we will enter the parameters. So I'm entering the parameters. So here I have entered all the parameters. Now click on predict button. So here we can see the result. There is an attack detected. Attack type is DDoS, that is distributed denial of service. Now we will enter another set of parameters and check whether attack is detected or not. So I'm entering another set of parameters now. So here I have entered another set of parameters. Now click on predict button. Here we can see the result. There is an attack detected. Attack type is probe. Now we will enter another set of parameters. So click on home. So I'm entering another set of parameters now. So here I have entered all the parameters. Now click on predict button. So here we can see the result. There is an attack detected. Attack type is R2L. Now we will enter another set of parameters. So I'm entering the parameters. So here I have entered all the parameters. Now click on predict. So here we can see the result. There is an attack detected. Attack type is U2R. Now we will enter another set of parameters. So click on home. So I'm entering another set of parameters now. So here I have entered another set of parameters. Now click on predict button. So here we can see the result. There is no attack detected. It is normal. In this way, just by entering the parameters, we can predict whether attack is detected or not. Now click on sign out button here. The conclusion of the project is the project involves a comparative study where the LAD method is pitted against established machine learning algorithms like support vector machine SVM, Navy Bayes, random forest RF, and decision tree DT. This comparison includes evaluating the performance metrics such as accuracy, precision, recall, and FN score using the NSL KDD dataset. The aim is to assess which method or algorithm performs better in detecting network intrusions. The project finds that the LAD method is successful in detecting intrusions within network systems. This success is indicated by the ability of the LAD based intrusion detection system IDS to effectively identify and classify potential intrusions based on rule based patterns derived from observed behaviors in network data. Utilizing the NSL KDD dataset, which is widely recognized as a benchmark dataset in network security field, adds credibility and trustworthiness to the project's findings. This dataset ensures that the results obtained from the comparison of different methods are reliable, generalizable, and reflective of real world network intrusion scenarios. The project emphasizes the significance of behavioral based intrusion detection system IDS approaches, specifically citing the LAD method in effectively identifying patterns and classifying observations for enhanced network security. By focusing on behavior rather than just known signatures of attacks, these methods have the potential to detect novel and evolving threats in network systems.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.